Today we are going to handle undercurrent electricity, EMF of a cell, terminal potential difference, lost volts, and internal resistance of a cell. This EMF, internal resistance, lost volts, and terminal PD are represented, they are related by this equation on the board.
Welcome to today's class.
E is for EMF of a cell. Capital V is for terminal PD. While small letter v is the lost volt. What is EMF of a cell? Let's start by defining EMF of a cell. EMF of a cell is the potential difference across the terminals of a cell when it is in an open circuit. Let's take this for instance to be the symbol for cell. Remember, it has terminals. EMF of a cell is the potential difference between the terminals of a cell when it is in an open circuit. That is, when it is not delivering current to an external circuit. An open circuit is one where no current flows. Remember, this is a cell. This is a positive terminal. This long one represents the positive terminal. These parts represent the negative terminal. So EMF of a cell is the potential difference across the terminals of a cell when it is not delivering current to an external circuit. Then we have the terminal PD, which is this one. The terminal PD, represented by capital letter V, is the potential difference across the terminals of a cell when it is delivering current. This one, current flows, is equal to IR when it is delivering current to an external circuit. Then the lost volts, that's this small letter V. The lost volts is the potential difference across the internal resistance. That is why it's equal to IR. This small letter R is the internal resistance. So lost volt is the potential difference across the internal resistance. Then we have another one which is the internal resistance. What is this internal resistance? From the name resistance, let the word opposition come to your mind. Internal resistance is opposition offered by a cell, the opposition to flow of current offered by a cell. So we have gotten this. We can factor out I and have R plus internal resistance. Okay? So that current, make current the subject of the formula. You know, you will divide here by R plus small letter R plus. So that current standing alone, current will be E into R plus internal resistance R. So this will give us, they can ask you to calculate the current, the EMF of a cell, the terminal potential difference, the lost volts, the internal resistance, the resistance through the external resistor. Let's take this example. A battery of EMF 24 volts and internal resistance 4 ohms is connected to a resistor of 2 ohms. What is the terminal PD of the battery? In current electricity, try to draw the circuit diagram. It will give you better understanding of what you're looking for. Okay, this is what we have. Then we are given that the EMF is 24 volts, E is 24 volts, the internal resistance is 4 ohms, then we have the external resistor as 2 ohms, and we are asked to find what is the terminal PD of the battery. We are looking for the terminal PD of the battery. V, capital letter V, is what we are looking for. Remember that from this we have that E is 24 volts, R is 4 ohms, current resistor, the external resistor is 2 ohms. We don't have the current. So let's first calculate the current. Using this formula, let's get the current. Please always write the formula when you are solving a theory question so that you get mark for the formula. E is 24, R is 2 plus 4. That's, we have 24 over 6. The current will be 4 amperes. So if we are looking for the terminal PDV, we can go ahead and use that terminal PDV is equal to IR. This will also give you the answer, which is I 4 times R, which is 2. So we can have it to be 8 volts. Before we go further, there is something I want you to note about cells in series. These cells are in series. The total EMF will be E1 plus E2 plus E3 for cells in series. And the internal resistance R as well is going to be R1 plus R2 plus R3. That's for cell in series. But if we have it like this, that cells in parallel, the effective EMF is going to be just E1, the same as E2, the same as E3. One covers for all, for cells in parallel. And their internal resistance, 1 over R, will be 1 over R1 plus 1 over R2 plus 1 over R3. Please, if you did not learn any other thing today, note these two things. Cells in series and cells in parallel. Their combined EMF, their combined effective resistance, and for that of cells in series. Let's take this second example. An electric cell with nominal voltage E has a resistance of 3 ohms connected across it. If the voltage 0.6 E, the internal resistance of the cell is, this question came out in JAMB 2002. How do we handle this kind of problem? Let the EMF of the cell be equal to that nominal PD, which is E. Then has a resistance of 3 ohms across it. R is giving us 3 ohms. If the voltage falls to 0.6 E, if the voltage, let's say the terminal PD now is 0.6 E, Find the internal resistance of the cell. We are looking for R, which is the internal resistance of the cell. Recall that E is equal to V plus the lost volts. From this, we are looking for R, which is here, and no current is given in any of them. No current is given. So we are going to use this. Remember that V is equal to IR. V is given as 0.6, R is given, but no current is given. So we have V that 0.6 E is equal to I times R. R is 3. I times 3, which is 3I. Remember, I is the current, 3 is this ohm. So we have gotten this as equation 1. We have gotten this from this. Remember this from Ohm's law, if you can still remember. The terminal PD gave us this. So we'll go ahead and check. EMF of a cell is equal to terminal PD plus lost volts. It then means that terminal PD, this one crossing over, will give us minus V is equal to lost volts. If I want to write this one here and have it like this, it's still the same thing. Okay. V, lost volt is E. E is still E. Minus V is giving us 0.6 E. 0.6 E. So the lost volt will be, this is 1 E, but we don't write 1 in maths and physics. 1 minus 0.6 will give us 0.4 E. And remember that lost volt is IR. 4E. We have gotten a second equation. You see how we got two equations that have current. So what are we going to do? Let me make this better by saying that 0.4 E is IR. They are equal. Anyone you write first is still the same thing. Okay, now I'm going to solve this equation together. Let me make current the subject of formula here, so that current will be 0.6 E over 3, and current here will be 0.4 E over R. Now, for this circuit, the same current flows through. If the same current flows through, then this is equal to this, so that we can have 0.6 E over 3 is equal to 0.4 E over R. So we'll go ahead and solve this times this times this. Remember that E can cancel E, but let's cross multiply first and have 0.6 E times R is equal to 3 times 0.4 E. So that E can cancel E, then R will be 3 times 0.4 over 0.6. R will be 3 here 1, 3 here we have 0.2. This will cancel, so at the end we are going to have R to be 2 ohms. So this is how to solve this kind of problem. He gave us two equations. Since it's the same current, this is equal to this. Then we have the internal resistance as 2.